All right. Okay, so this section is on data visualizations. I know that if you've been going through all of the labs, which is not super expected, but there is one lab that talks about doing visualizations with pandas. And I had mentioned before, but that doing the visualizations with pandas in their backend actually has built-in Matplotlib. So when you're doing your plot with pandas, you're actually using Matplotlib, and I'll get a little bit more into that. But before talking about how to do visualizations, I think it's important to talk about why do we make visualizations. I think it's often overlooked because it's not very quantitative, right? It's a picture, and you don't really get numbers out of it, but visualizations can be really, really helpful. I actually it was kind of funny as a joke. I was like looking on Glassdoor, and I noticed there's a job position called data visualization consultant, which is like interesting. So data visualization consultants, they consult on the graphs. So I still don't know what they do really, but they get paid about the same amount as data scientists do, which is interesting. So I don't know, if you like data visualizations a lot, that could be something you look into. But yeah, why do we make visualizations? I think I'm going to show you guys this site. It's very interesting. This is an interesting website, because you would think like, okay, if I have like all the summary statistics, if I have like the mean, the quartile range, standard deviation of data, shouldn't that be enough? So this is a really funny graphic. I like this graphic a lot. It's called Datasaurus. It's called the Datasaurus. And each one of these scatter plots, all 13 of these scatter plots, have the same summary statistics. So they all have, on the X value, a mean of 54, Y mean of 47, same standard deviation, same correlation between their X and Ys, and they all produce these different scatter plots. So without visualizations, right, we might be getting something that looks like a dinosaur and something that looks like maybe this X over here, and we're like, huh, very similar data, but evidently not. So visualizations are just like a really good way to look at a snapshot of your data. Yeah, I just always think this is funny. When I used to work on campus, I actually printed this out and stuck it like where I used to work. This is just funny to think about, that like all of these scatter plots have the same distribution. Well, not distribution, but they have the same summary statistics. Well, so that's why I think that's like a good starting point of why visualizations are important. Going back to the notebook, and I have like linked this here if you want to read more about it.
Yeah, can you share this link?
Yeah, it's in the notebook. So if you like have these, if you get the site email down, you'll have the link as well. So yeah, so data scientists using visualizations, I think we can really bucket this into two buckets of how we use visualizations. The first is in an EDA, and you are all going to be doing EDAs for all of your projects. It's exploratory data analysis. It's basically to explore what data you have, because oftentimes you get gigantic data sets. You can get these summary statistics by doing a df.describe very easily, but you know, you really have to form visualizations of all your features, of all your columns, to really make sense of your data. And we're going to talk about that a lot more in context when we get to our projects. So we're really going to explore the data that we have, find out more about what we're working with, and we're trying to discern patterns and relationships that can maybe drive our modeling process, drive like the decisions that we're going to make. From visualizations alone, which is your project that you're going to be doing at the end of the mod, you can maybe come up with like actionable insights for a company based on like the data that they have that is maybe not as clear by numbers alone. So exploratory is one bucket, and the other bucket is explanatory. So oftentimes as data scientists, part of our job is actually to explain what we are doing to non-technical stakeholders, which is why as part of the project, you also have to do a non-technical presentation and also have to write a blog about it. this process of explaining doing something technically to non-technical people is extremely important. It's, I think, what a lot of cultural and actually in part technical interviews is that's a lot of what people are looking for. If you can translate all of this crazy coding work that you're doing to someone who doesn't know code at all, that is a really, really vital skill. And visualizations help with that immensely. So let's say you wanna suggest to someone, hey, maybe you should do your product this way, and this is why. So when you're telling them why, you would usually have a presentation of like a bunch of scatter plots or line graphs or like trend graphs showing why. And these visualizations will really help, like, you know, make that connection between like the technical and the non-technical. So it's for stakeholders to convey our narratives, our takeaways, and our insights. So this is just really to like set the stage for like why we're doing these visualizations, because I think very often, especially as students in a boot camp, we tend to forget that like how important EDA is. And we're gonna see that very, very evidently in our end of mod project. Any questions so far about like the motivation of visualizations?
So any set of questions that is regular or any a set pattern for the EDS that, okay, if you go through this structured way, right, you will be able to get the analysis properly.
It really, really depends on your data and also the context in which you're given like a project. So for example, like let's say a manager comes to you and they're like, okay, try and give us a model on like what should we do next quarter. Let's say, okay, I'll use the project as an example. So the project, you're actually posing as a data scientist working for Microsoft, and in the project, in the prompt, if you guys have, it's up there, so you can totally read it now if you want. The prompt is that Microsoft wants to start their own streaming service, and based on movie data, what would you recommend that they do in terms of like, I don't know, it's very open-ended. What would you recommend that they do in terms of like maybe what kind of movies should they make? What kind of actors or directors or producers should they be hiring? That kind of stuff. And you're based on the data that you're given or based on the data that you have, your EDA will be very different. And in this case, because we're already given a prompt, like, okay, yeah, maybe for a streaming service, we want to maximize like the number of new subscribers. So let's take a look at like all the columns that will maximize popularity. So maybe there is some, like, I think in the data set you have like IMDb ratings or like Rotten Tomato ratings or something like that. And maybe just like looking at those columns and taking a look at how those columns are related with other columns. So because this project has like already has a goal, it's kind of guided in that way. In other projects, sometimes I think it's very common in startups especially, you're just given a large data dump and they're like, find us something to do. And in that case, you really like, you can start from anywhere. I've definitely experienced that before where I was just given like a data dump of like user data and they're like, find something for us to improve. And I was like, okay. So I was just looking at like patterns, seeing if there are any trends that we're not really capitalizing on. Things like that. And that was just, I tell you, like, that was like weeks of looking at data without any idea of which way I was going. So it really does depend on like the context of which you are starting your analysis. But in any case, knowing how to make plots is extremely important. Awesome. Before we get into coding, any other questions? All right. So for coding, it's a little bit finicky. I personally like Matplotlib is not my favorite library. There is another library that they actually don't talk about in the curriculum called Plotly. I'll send that out later for anyone who's interested, but most people like Matplotlib. Not my favorite, but I'm still going to talk about it. I definitely have used it before, and like it is very customizable, and that's a good thing. But yeah, just know that it's not the only plotting library out there. Let me just clear the output real quick. Cool. So when we're doing Matplotlib, what do we import? Interestingly, we don't just import Matplotlib. We have to import matplotlib.pyplot. I think it's just the structure of how they store all of their code. It's just that you always import matplotlib.pyplot, and the alias is PLT. That's just the industry standard. Some of you might have already seen this line. It is what is I think it's called a magic function. Whenever you see this percent sign, it's called a magic function, and this is very specifically for notebooks. It's just what allows the graphs to output in our notebook. So make sure that you always have these two things when you're working your notebook. And for this purpose, I'm also going to import NumPy and pandas as usual. In terms of data set that we're going to use, let's start with the car data set that we were working with for the past two sections as well. And to get a reminder, this is what it looks like. Data on cars, miles per gallon, cylinders, displacement, horsepower, weight, acceleration, year, and origin. All right, I've linked the documentation to Matplotlib over here, just in case you want to take a look. But here are some very common visualizations. There's a dot plot. Sorry, these are the kinds of visualizations, and these are the methods to get them. So line plot. So if you have like something that probably like goes with time or with any like increments, anything that's sequential, you use a line plot. Scatter plots, probably the one that I use most, because scatter plots are great at looking at the relationship between two variables. Regular bar graphs, which are similar to histograms. Does anyone know the difference between a histogram and a bar graph? Just out of curiosity. Yeah, it's one of the randomest interview questions I've ever gotten, and it's always stuck with me because I really didn't know, because I thought they were interchangeable. But histograms are for plotting frequencies, whereas bar graphs are more for plotting categories. And I'll show, I think I have an example of a histogram later on that I'll show. Yeah, I do. So I'll show that later. Horizontal bar graphs, which is just a bar graph that's like coming out from the side. Horizontal and vertical lines across axes. So sometimes if you have, let's say you have multiple bar graphs, and you just want to show like what the average is, sometimes you can just literally plot like a horizontal line showing where the average is, so you can see how the bars compare. Vertical line, same thing. And then stack plot. Stack plot, you can sort of imagine like, you know, those like stacked bar graphs. Let me just like quickly grab a photo. Stacked bar chart. Let's just do Matplotlib just to see. Matplotlib is great because there are a lot of examples. So this would be a stacked bar graph. Where you have like the two categories, but they're stacked in a bar. And as you can see, this is a bar graph because these are categories. This, I don't know what this is, but let's see, G1, yeah, I guess these are just different categories, but they're not frequencies. So this is not a histogram. Let me actually just quickly show what a histogram is. Examples. Maybe this one. Right. So a histogram has like either probability or frequency, or like the count. And this is basically like how many people have an IQ of 100, how many people have an IQ of 120. And it would just be binned and it looks like this. Does that make sense, the difference between bar graph and histogram? Awesome. That was just a little tangent. Cool. So the way you start a Matplotlib graph, I sort of like to think of it as like you have a canvas and then you're putting pieces of your graph on one at a time. That's kind of how Matplotlib graphs are written out. So let's start. Usually you always start and end with like what graph it is, and then you always end with plot.show because that's what lets you show the plot. So if I just run this, so what I'm doing here is I'm just doing plot.scatter. So you start with plot because that's what we imported, and then you would just do dot whatever you want to visualize. I had opened this earlier, and this is all of the methods that you can use. So over here, there are like just 7, but let me move this bar away. But over here, you can see there are so many different kinds of plots that you can use out of PLT. There's just, yeah, a lot of stuff. And we're gonna keep coming back to this. Anyways, what I'm doing here with scatter, let's take a look at scatter and what scatter says. Scatter is over here. Let's make this a little bigger. So scatter gives you a scatter plot of y versus x with different marker size and or color. And the way you take it in is you feed it in the x, whatever you want on the x-axis, whatever you want on the y-axis, and these are just all the optional arguments. So you can change like what shape you want the marker, what color you want the dots to be, stuff like that. So let's start with this. We're going to start with plotting the displacement against horsepower, or horsepower against displacement. And we're just going to label it car for now. Awesome. So right now you can see that these values are the displacement values for each car, and this is the horsepower for each car. Can anyone tell me what kind of relationship or correlation we see here? This is like a back to section 3. What's up?
Linear?
It is a linear relationship, yeah. And it's a linear relationship, positive correlation. Positive because it's just going up towards the right, and it looks like you can sort of fit a line. It sort of looks like there's like, you can fit a line pretty nicely. So cool. As I mentioned, building a Matplotlib graph is like starting with a canvas and then like putting the parts on. So this graph is pretty plain. Usually it's very good practice to always have like titles and also your axes labeled. So these lines over here with all the numbers, those are your axes. This is generally called the x-axis. The horizontal is usually called the x-axis and the vertical is your y-axis. And you usually want to label what that is. So let's do it step by step. So first, what I have here, I'm going to add the title. And for here, I just put the relationship between displacement and horsepower. And you can sort of notice that like all of them, I'm just taking PLT dot whatever it is. So it's sort of just like adding on. So if I run this, you can see there, automatically we have our title. Next thing we want to do are X labels and Y labels. And this, to be honest, I had to look up. So I don't always remember these as well. I don't even like look at this and try and find like, is there what I need to do? I literally will Google like adding labels to axes of Matplotlib, and you'll find a bunch of good examples. Anyways.
So one quick question, Yash.
Yeah.
What do those, I mean, how do the dots which are there inside the plot, right? What do they actually indicate? So there is only a single indication, or there are two things which are being compared there?
Yeah, so each dot is a car.
Okay.
So this car has a displacement of about 230 and a horsepower of about like maybe 165.
Okay.
So it shows the relationship between the two variables for like each car. So you're saying, so like an example question would be like, okay, if the displacement goes up, does the horsepower usually go up for a car? And so based on this graph, you can see like, okay, for most cars, if you increase the displacement, the horsepower goes up.
Okay.
Yeah, so each point represents a car, and then you would just like trace back what their values are. But most of the time when you have like exploratory graphs like this, you're not really looking at each point. You're more so just like looking for an overall trend or pattern.
Okay.
Yeah. But anyways, back to this. And by the way, do we know this shortcut for like commenting and uncommenting lines?
Yeah, I think the control question mark.
Yeah. So if you're on a PC, it's a control question mark, and if you're on a Mac, it is command question mark. And this, I use this a lot. So anyways, so once we have these plt.x and y label, and I just like fed it in what I want the labels to be, you can see here, it's a little more clear, right? So I don't have to keep like looking back thinking like, oh wait, what was this graph about again? Because they're written right here. And finally, you want a legend. Usually you want a legend that is, if a graph is a little more complicated, you want a legend, but just for the sake of this, each point is just a car. So this is not going to add much more information, but you can add like a little legend like this just to say like that this is the car. So usually if you have like different categories on one graph, you can say that like blue is the car, orange is something else. So this is kind of the structure when you're building a plot. You would just take your, you would just build something ground up.
So if let's say if I want to add something like instead of car, there is a bike. There are like if I want to add bikes here, right? So on the top line, I would change the DF or add the DFs.
So if you want to, so it
data
depends. It depends. If you want to plot something completely different, you would just change these, like change the columns that you want to plot. If you had like another data set, let's say you had another group of cars with like displacement and horsepower and you wanted to plot the scatter on top, you would literally do another line of plot.scatter and maybe you had like a different data frame with different displacement, different horsepower, and then you can just do that as well. And usually automatically, if you have different data, wait, let me think what I'm trying to say. If you're doing different scatters, it will automatically give you different colors. So actually, I can do this right now. So let's say I segment this data set to get like 50 points from the top to be one color and 50 points from the bottom to be a different color. Let's just copy and paste this. I'm gonna call this car 1, car 2, and let's do this as 50 to 100. Is there 100 in this data set? I forget. So df.shape, okay, we're good. So let's do 50 to 100. And there we go. So you can see that it recognizes that it's two different things that I'm plotting. So 1 to 50 is the blue dots, and then 50 to 100 is the orange dots. Does that answer your question?
Yeah.
Yeah. So it's a little different from like, I feel like the syntax of this is a little weird because you're literally just like making new lines of code, but that's just how it is.
Yeah, I've kind of a question about that. So how does like it know it's all the same? You're not assigning it to a variable. So how does it know it's the same scatter plot and let's not create two different scatter plots next to each other or something?
Yeah, I will get into that a little bit later. So usually there's another layer that comes above this, and I'm gonna get into that. There is actually a figure layer that comes above this. So if you're just making like a one-off graph, this works. But if you wanna like make multiple plots, I'm gonna talk about that as well.
Yeah, one quick question. Because I thought for the project we were doing something like df.map, and then we try to create the graph. But now we're using like plt.scatter. So I get like, what's the difference between the two?
So yeah. So let's see. So that was like the project for like sections 4 or 5, right?
Yeah, it was in section 5.
Yeah. Okay, yeah. So
when we were graphing, you were using map all the time, not so much this.
Map.
Yeah.
Oh, interesting. For map, I'm not too sure. I just know that if you're doing it straight out of a pandas data frame, if you're using the pandas plot functions, they're completely different. Even though they do the same thing,
Okay.
the like the actual like methods that you use and the way that they take in arguments is different.
Okay.
Yeah, usually like I just like to do my plots separate from the pandas built-in ones. But if you're doing like something one-off and you just want to like look at how like a couple variables look, totally like, yeah. I think it's also personal preference. If you like the built-in pandas ones, feel free to use those as well. As long as you can generate the graphs that you need, I'm fine.
Gotcha. Okay, thank you.
Yeah. Let's see. Right. Okay. So any questions about this?
Just a quick one. Will it still work and just ignore data if you don't have if your X and Y don't contain the same number of data points?
If your X and Y don't contain the same number of data points, it will not. It will actually give you like an axis mismatch, I think. So if we do this, there we go. So they'll say X and Y must be the same size. and they'll tell you it is at line 2, which is for the one that I changed to be not the same number of points. But yeah, so it has to match up. That's a great question. So yeah, that'll work. I think if I can, let me see if I can do this. Okay, never mind. I wanted to see. So some data types, some data can be represented in different kinds of graphs. So I just wanted to see if this one was one of them, but no, because histograms take in just one variable. Anyways, moving on. When you start working with slightly more complicated graphs and you're not doing just one, you're gonna see these come up a lot. So you'll see figure, some keywords to remember, figure, axes, and subplot. So technically what we did here is axes. Each of these scatters that we made are an axis. Figure would be this entire thing. And subplots we'll get into it in a little bit. All right, so let me just run through this code. So these are histograms. Here I think these are just random. Yeah, this is just a histogram of all the weights, I think. No. I labeled it wrong. Sorry. So this is the weight and this is the year. And these are frequencies. So how many times do we see a car that's between like, let's see, what, like 2,000 and I think 2,250. Yeah, I think because each 1,000 is in 4. Anyways, histograms. What I'm trying to get at here is the big canvas that I was talking about is the figure. So here is where we define a variable. And so figure, plot.figure, I can call that figure. And so anytime I want to do anything to this graph, I would just refer to figure. And so under figure, there are some attributes that you want to define for the entire figure, whereas there are some attributes that you want to define for each axis. So each of these individual graphs is an axis, also a subplot. So that's another terminology. Axes are kind of subplots. Axes and subplots are kind of the same thing, but axes can be laid on top of each other, but subplots specifically are if you have like multiple graphs in one figure. Is that confusing? I'm gonna say that again, probably better. So axes just refers to any graphical representation of the data. So each of these, the blue dots are an axis, the orange dots are an axis. Here, this histogram is an axis, this histogram is an axis. But each of these are also subplots because they're two different plots within a figure. I think a good example is in the Learn Labs. Let's see, there is a Subplots and Enumeration Lab. And if we look quickly over here, I just want to show you guys what a subplot is. Something like this. This is not a good one, but you're still gonna have to do it if you do the lab. But anything with like multiple graphs in a single figure is a subplot. If they are on top of each other, if let's say like similar to the scatter plot that we did earlier, where you just have like one set of data, but then overlaid on another set of data, those are just two axes. Do we get that? It's kind of like
we just give you, if we want to compare two things, and if we just say that, okay, whatever, let's say axis PLT dot subplot, right? It will give us two figures, correct? Comparatively?
Yeah, kind of. I'm going to get into like the syntax for subplots because it's a little bit different. So anyways, there are some attributes that belong to the entire figure. And this is an example, subtitle. I think it means for super title, but I don't know. But based on the documentation, I saw that like subtitle is actually a centered title to the figure. So no matter how many subplots I have, this will be like the main title, basically. And I can also actually add titles to each individual axis. So anyways, with subplots, you add figures to a subplot. And just to make things easier, you don't have to do this, but you would, I think it is easier actually to do this, but I do assign a subplot to a variable. So in this case, and if you read the documentation, these numbers kind of make sense. So what these numbers mean, 121 versus 122, they're not 121 or 122. It's 1 row, 2 columns, graph 1. And then for this one, it's 1 row, 2 columns, graph 2. So if we mess with these numbers and like change this to like graph 3, I think it'll say like out of range. Yep, so number must be between 1 and 2, not 3. So that's what these numbers mean, because sometimes I think without context, they're like, what is 121? But anyways, so I have basically 2 subplots, and I'm just going to call them, I don't know why, but like the standard is just to call them ax for axes, even though it's a subplot, but subplot is also an axis. But anyways, you would define each of the axes separately on its own. So here I'm just making a histogram of the weight, and you see I will actually set the labels to the axes. You notice that this set X label, Y label is different from the way I did the label here. That's a really irritating thing about Matplotlib for me as well. Is like, if you're using a method on an axis versus a method on just a plot, it's slightly different. So these are things that I'm looking up constantly. But anyways, for axes, there's this set function where actually you can just set, you can set almost anything. I think in here you can even set, I want to say color. Let's see, maybe it's not called color. I think it's called something else. Maybe like, see, never mind. We're not going to test this now. But if you look it up, you'll be able to find what is the correct argument to set the color. And a lot of it will be nested under this one set method. So with subplots, yeah, I explained what these numbers are, and you would set all of them separately. Questions?
So can the subtitle and the titles, right, be used simultaneously, or only one can be used?
Could you say that again?
So the subtitle and the title. So let's say if we want to give a title for all the figures and then subtitles for each one of them.
Let me check if it's this one or it's in the set. I think title, let me see. So it is not here. I think it might be here. There we go. So we can set titles for each of the subplots as well.
So, but then you have to pass the title inside the set. So if you keep it outside, it does not run.
Yeah, because this is the specific way you set these attributes for a single axis.
Okay.
Yeah.
So what does the plot show do? Because like what works on my computer when I delete the plot show.
Yeah, it does work. So if you take away plot.show, this is the only thing that like comes up. So if you don't have plot.show, you'll just get this output here. So plot.show is just shows without those outputs, just so that there's something to output on a notebook. Cool. Any questions before we move on really quickly to Seabourn? All right. Seabourn is another library. Actually, most of my students end up using Seabourn the most because Seabourn actually is Matplotlib, but pre-packaged in a slightly nicer way. And it is pre-packaged specifically for like, if you want to look at very specific like statistical plots. So Seabourn has the alias SNS, And for this case, I'm just gonna take this random data set of making a random, I think I did take this from the lab. What data is, it is 20 rows and 10 columns of random numbers. And then you're broadcasting the numbers from 0 to 10 divided by a half. That doesn't make sense, but let's take a look at the box plot. So Seabourn is really, really convenient in doing like very specific plots. For example, box plots, or I think some people call these box and whisker plots. If you're later when we get to statistics and we plot things with like normal distributions, Seabourn is also good with that. But Seabourn can do all of what we can do in Matplotlib as well. But Seabourn typically has nicer colors, and also the syntax to most students is a little easier. So all we need to do for this, it kind of automatically detects things as well. So it's just SNS.boxplot data equals to data. And then to set all these things, it's also similarly in a dot set where you do all the labels and then the titles here as well. And then I think we can just do boxplot to see what it is. Or this. So I personally don't really use Seabourn, but let's do this here. There we go. As long as it's in the same cell, it'll work. Cool. Any questions?
Can you explain it once again?
Oh yeah, of course, of course. So let's take a look at this data. Actually, let me just put it in a data frame so it looks easier. It's easier to see. PD.dataframe data. So this is just a randomly generated sample of data, just random numbers. And all we did is just we took this data and put it in a box plot. I totally forgot to describe what a box plot is. But basically, for each column is represented by each of these boxes. The lines on these boxes, middle line is median. We have our interquartile range, and I think this is min-max. And these are outliers. I need to double check on that. But yes, typically that's what a box plot is. Cool. I think this and this might be interquartile range and this might be something else, but it's a good way at looking at how your data is distributed across multiple columns at the same time.
I think the actual box is from, the 25 to 75, like the inner portion of that.
Yeah, so this part, right?
Yes, the bottom and the top part of that actual box, and then the interquartile and would be the bottom part of the box to the bottom of the line, and then the top 75 to 100 would be the top of the box to the top line.
Ah, okay, yeah, that makes sense. So the colored part is the interquartile range, and then min max, and I think these are just like outliers.
Yes, those dots would be the outliers.
Thanks, Edward. Cool. Any questions? I think the hardest part about plots is not so much the syntax, but like what plot should I use for my project? And that is something that we will get to when we start discussing the project. Cool. Any questions about visualizations, about anything that we talked about up to this point? Cool. Just to let you guys know, in terms of like plotting libraries, most students just pick one and stick with it. So this, like going through the labs, if you prefer Matplotlib over Seabourn or Seabourn over Matplotlib, just stick with one. You don't need to know both, for sure. You don't need to know both. So depending on which one you like more, that's the one that you should like stick to and practice with.
You recommend Seabourn, huh?
What's up?
You recommend Seabourn.
Most students like Seabourn. I personally never really use Seabourn because I use this other library called Plotly. But yeah, if you want to check out Plotly, feel free as well. Plotly is cool because the graphs are interactive. I think I can show an example. Let's see, Plotly. Here, I like Plotly a lot because they're kind of interactive. Let's see if we can get some examples. Oh, gallery. So here we have a scatter plot of like 3 different things, and you can like hover over and see, just see like their different attributes. So I personally like this library, but the syntax for this is, the issue with this is they keep changing their syntax. So yeah, it's up to you which one you want to learn. I have the most experience with Plotly, but I also do know Matplotlib. Seabourn actually wasn't out when I was learning how to code, so I think that's why I never really got into it. But yeah, definitely like pick your poison and then just stick with it.
Which one will be good for 3D visualization? So
3D visualizations, all of them actually do 3D visualizations. Fine. Yeah. 3D visualizations, actually funny enough, there's a lab on best practices for data visualization, which is, it's a light, fun read just to think, like have these things in your mind of like, what's a good graph? There's a whole spiel about, in the data scientist world, it's like, never use a pie chart is something that people say. Like people just hate pie charts. Yeah, don't use a pie chart. And similarly, they say something about like, don't use 3D visualization because 3D visualizations is harder to actually see what's going on. But if you have a very specific case, then yeah. I know that, yeah, I think, yeah, I'm pretty sure that all Seabourn, Matplotlib, and Plotly do 3D visualizations. It's just like, I think this is a good time to just like try out the different syntaxes and see which one you think is easier. So Matplotlib is generally more customizable.
Can that data, the data which you have put in, right, can it be put in a 3D?
This data?
Yeah.
Right now, I can't do it. I don't know off the top of my head. I would have to do some Googling. I can, let's see, I do have an example of a 3D plot that I can pull up that I do have. Let's see. The thing is with Plotly is just more interactive. So 3D plots just make more sense with, this is very, very messy. So this is an example of a 3D scatter plot that I did before. So this is made with Plotly. So 3D scatter plots, I think, work better with Plotly because you can do things like this, zoom in and out. You can also rotate to see different angles, which I think is more helpful for 3D. But yeah, if anyone's interested in ever doing a 3D plot, I like Plotly the best. And like the syntax looks something like this, where you do like plot scatter, and then you're like, actually Plotly is great because you can just tell it, give it a data frame and tell it which columns from the data frame to pull out. So that might be interesting, but I think Seabourn does the same thing. So yeah. A
lot of research to be done.
Yeah, so moral of the story, I think just pick one. Most students like Seabourn. But I think each of them has their pros and cons. Like Matplotlib is very customizable because you can introduce all of these attributes to your axes. Seabourn is by default nicer because their color palettes are just nicer. So I think that's why a lot of students like them. I think by default you just have these, yeah, nicer colors. And Plotly is just the interactivity. But yeah, I will say take like the next couple weeks as we're working with different plots to just choose the one that you want to work with. You're not married to your choice, so yeah. Cool. Any last questions? Awesome. In that case, I will see you all at your one-on-ones. Remember that for this week's one-on-ones, I want to talk about that section 5 project. the superhero data set. It's very, very open-ended, so you definitely don't have to like feel like you have to do a bunch of work. But you can totally like incorporate some of this plotting into it, so you don't have to use the pandas built-in one, or if you want to use the pandas built-in one, do that too. But yeah, I just want to see like at least a little bit of maybe a couple graphs and how you've like cleaned the data, especially.
So I mean, it's like we will be discussing on the project, right? Completely.
Yeah, unless you have other questions, we'll mainly be talking about that Section 5 project. I just want to see what your thought processes are and like how you worked with like cleaning and grouping the data.
Okay.
Awesome. And as usual, any questions you have, feel free to Slack me. But if there are no more questions, have a good Monday night, everybody. Bye, everyone.